This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. As we move closer to the launch of the Artemis 1 mission to the Moon, I thought perhaps a bit of orbital mechanics would help everyone to understand the difference between the Apollo missions and the Artemis missions. Here on Houston We Have a Podcast are Nashood Moranci and host Gary Jordan to explain the different types of lunar orbits for the first three Artemis missions.
It's a different mission for a different objective, right? So with Apollo, the objective, as laid out by President Kennedy, was to go to the moon as soon as possible, essentially by the end of that decade they were in, and return safely to Earth. So to do Apollo, you picked the easiest place on the moon to go to, the easiest architecture, so a single launch architecture, landing at the equator of the moon or very near the equator, and coming back with a very short mission, maximum of about 13 days of a mission. With Artemis, what we're trying to do is really set the stage for long-duration space exploration and explore the south pole of the moon, where there's way more scientific interest with permanently shadowed regions, way more opportunities to collect science data, as well as support long-term technology and habitation development with longer periods of sunlight than the equator. But to do that, it's higher performance, more challenging, lots more effort needed to go into it, as well as smaller budgets, because we're doing it on a sustainable basis, not a full-up national priority. So it is really a different mission architected around different objectives. And so there is a difference in what we're trying to do. Yeah, so orbital mechanics and the sort of the architectures, the trajectories are what underpins all that mission design. So for Artemis 1, you said DRO for the listeners, that's a distant retrograde orbit. It's called that because it's very far from the moon, very high altitude, so about 40,000 miles from the surface of the moon in a sort of ellipsoid. And that is retrograde because it's rotating the opposite direction the moon is going. So just sort of backwards if you look at the way the moon is. So that orbit we're used, it's in the Earth-Moon plane, means it's flat. It's around the moon's equator. And it's used because it's a very stable orbit. So if you want to park something there, you don't need you don't need any propulsion capability to stay there, but it's a really good test orbit. It came up early in designs of lunar architectures. And so that's why we're using it for Artemis 1. And it's also very good at what we need, which is that variable duration. Because we were in the DRO, we found that it could be used to do this duration change to get what we wanted for Earth entry conditions. So this orbit is a really good stable orbit, meets all of the objectives to test Orion in deep space. But whereas when we move to Artemis 2, we're actually not going to go into a lunar orbit. We're first going to do a high Earth orbit, followed by a lunar free return flyby. So that allows us to check out Orion with the crew systems around Earth. Very safe. We can abort much quicker from it. And then if everything's good, though, we'll proceed to let the crew do a lunar flyby, and we actually use the moon's gravity to slingshot back to Earth. So Artemis 2 was very much designed, that trajectory, that mission design, about what is the best way to do a crewed test flight. And then when we get to Artemis 3 and we want to land on the moon, we go into a near rectilinear halo orbit. So those are a lot of big words for a very large ellipsoid orbit that actually is out of plane. So rectilinear, it's about 90 degrees out of plane from Earth-Moon. So it goes down below the moon, around below the South Pole. And that orbit is also a stable orbit, but it provides that South Pole access. So very key there, because on Artemis 1, we're not landing on the moon. So we didn't need to change the plane of the orbit. For Artemis 3 and beyond, we want to go to the South Pole. So we're doing that orbits north-south, essentially, over the moon. Yeah, so that South Pole access for Gateway, long-term stability to build out a cislunar habitat outpost around the moon, and the lunar access to get down to the surface on the South Pole. So there's sort of a balance of objectives in how we selected the NRHO orbit.
And for Artemis 1, to complete the story on the DRO, distant retrograde, the reason for the variation in the potential times is it really just how many laps around that DRO orbit? It's really just about laps.
It is. So on the shorter missions, we'll stay there for half an orbit. It's a 12-day orbit period. So it takes 12 days to go just once around the orbit. So for a shorter mission, we only spend 6 days or so in the orbit. When it's a longer mission, we go 1.5 times around the moon. So you spend about 16 days in that orbit.
Nishut sums up the importance of the lunar missions and what keeps her going.
What's really those driving factors that get you up every day?
I think you're laying it out right there, right? We get to make a difference. What we're doing is important. And it's not just important for us or America, it's important for humanity. Exploring isn't just about the science return. It's about the technology. It's about the business. It's about how do we, as a human species, come together. So getting to be a part of that is huge. And, sometimes we forget because you're in the day-to-day of it. And, you just went to that meeting that did not go so well. But then you look up and you talk to other people and you realize how important it is. And so that's why you just keep at it, right? We're all in this because we believe in the mission. And you can't understate how important that is.
It's exciting territory as we make plans for sustainable presence on the moon. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.